We are Group 3 of Operating System, Lecture Group 7. My name is Angelina Poyang Sulung, metric number 72109. For this project, Ilima's Web need to propose the best process scheduling algorithm to evaluate a job list, which is job list 7 containing 30 job processes. There are 4 types of process scheduling algorithm, which are first come first serve, shortest job next, shortest remaining time, and round robin. To find the best algorithm, we will take account on the average turnaround time, waiting time, and the number of interrupts. So, which one it will be? Let's get into each algorithm before determining the best of them all.
Hi, my name is Elvira Fahana and I will be presenting my part, which is the first come first serve scheduling algorithm. FCFS is the simplest algorithm among the 4. As we all know, FCFS is a non-preemptive scheduling algorithm whereby jobs are always executed on the first come first serve basis. Once a job has completed executed on the first place, only then the next job will start executing. Our group had chosen job list of group 7. Now this is the C++ implementation for the FCFS. From the job list, we get that 30 jobs are in total altogether. The first job holds the arrival time of 1 and job 2 is 67 and so on. From my coding, you can see that I call the function sort first to get the job with shortest arrival time. Then every time each execution happens, the program will start to calculate its start time. Then we get the total of the start time, complete time, turnaround time, and wait time. After all the job has been completed, then we can find the average for turnaround time and waiting time, in which we get the result of 28284.2 and 26406.8 respectively.
Hi, my name is Nina Naksudi. I will continue the presentation with shortest job next, also known as shortest job first. This is non-preemptive scheduling, which is process handle based on the length of the CPU cycle time. And here is the example of the output that count average of turnaround time and average waiting time. So now let's look into the source code. So here we already assign the value using array. So to perform the SJN, we have to find the shortest burst time and the shortest arrival time. If the index is found, then we will perform all this calculation. Or if the index is not found, then the current time will increase, and here the CPU is idle. Then we will display all the output of the calculation. So now, let's look into the output of this program. Number 2. So here is the new arrangement of this job list, and we can see that the value of first time job number 1 is higher than job number 23. But job number 1 will perform first because it arrived first. And here is all the calculation of turnaround time and waiting time for every job. And lastly, display the average of turnaround time and the average of waiting time.
This is Kitty John and my metric number is 784. I will present about the SRT algorithm. SRT stands for shortest remaining time, also known as shortest remaining time first, SRTF. In this scheduling algorithm, the process with the smallest runtime to complete is scheduled to run next, including new arrival. This is our program code. First, we create structure to store the job list. This is for program code of SRT algorithm. SRT algorithm is a scheduling method that is a preemptive version of shortest job next scheduling. Because the process with the smallest amount of time remaining until completion is selected to execute. If a process gets completely executed or the remaining time is equal to 0, the program will calculate the completion time, turnaround time, and waiting time as we can see in the screen. But if the remaining time is not equal to 0, the program will increase the number of interrupts. This is the output when we run the program code. The option number 3 for shortest remaining time. And press enter key. It will display the processes along with all details, include the average for turnaround time, waiting time, and the number of interrupts incurred. Alright, that's all for SRT algorithm.
Greetings be to Mr. Rajan. My name is Nur Elizia bintu Sulaiman, and today I'll be presenting regarding the round robin. So as we know, round robin is a preemptive algorithm where the CPU will be shifted to the next process after a fixed interval time, which is called as the time quantum. The efficiency will depend on the size of the time quantum, so it is best to choose the time quantum correctly. So this is the output of the round robin algorithm on job list 7, where we can get the average waiting time, average turnaround time, and the number of interrupts, since it is a preemptive algorithm. So now let us look into the program code. So firstly, we store the total job in an array, where this is the job, this is the arrival time, and this is the burst time. Then we set a list job value as the burst time, so the value of the burst time is not equal to 0 at the end of the calculation. Now we do the calculation. So this is the calculation when the job finishes execution before the time quantum, and this is the job. This is the calculation if the job enters preemption where the interrupt will be implemented, and this is how we calculate the number of interrupts. Lastly, this is the calculation if all of the jobs have finished execution. Now this is the source, the output. We click case 4 and we enter the time quantum, which is 10. And lastly, we can get the average turnaround time, average waiting time, and the number of interrupts. That's all from me. Thank you so much.
Hello, my name is Loy from matrix number 70238. I'm going to talk about comparison of the 4 of the algorithm and the most suitable algorithm on job list 7. Based on the graph given, we can clearly see that round robin algorithm have the highest average turnaround time and average waiting time, while the other 3 are almost the same among them. However, the data from the table recorded that shortest remaining time algorithm has the lowest average turnaround time and average waiting time among all of them. Since first come first serve algorithm and shortest job next algorithm are non-preemptive scheduling algorithm, which process cannot be interrupted till it terminates or switches to waiting state. Therefore, both doesn't have number of interrupt incurred. In order to be the most suitable algorithm on job list 7, the algorithm should be a preemptive algorithm, the algorithm where a process can be interrupted in between and take the shortest time to complete whole process in job list 7. In conclusion, based on the comparison, the most suitable algorithm on job list 7 is shortest remaining time algorithm, since it is a preemptive algorithm and it takes the shortest average turnaround time and waiting time even its number of interrupts incurred higher than round robin algorithm. That's all from me. Thank you.